Welcome to Multiple Choice Question 15 of the 2006 Mathematical Methods Exam 2. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I'd just like to point out that the use of the CAS calculator is not really appropriate for this question, as there's no way to actually input what we're about to see into the calculator. By all means, the use of your notebook would help to answer this question. For question 15, we're asked the total area of the shaded region in the diagram below is given by one of the following options. And from the diagram, we can quickly observe that there's two regions that are below the x-axis, so their integrals, unless we change them, would have negative signed area associated with them. So we need to look through these options and work out which one adds up three positive quantities for the area. So straight away, if we look at option A, we can see that it's just treated the whole area as one integral, which would add up two negative values and one positive value, which wouldn't give the overall area for this question. So option A is not correct for this question. For option B, we have the integral from negative 1 to 0 of f of x dx plus the integral of 0 to 6 of f of x dx. So what that integral would be trying to describe, and it is incorrect, is that the area on the negative side of the y-axis is the negative area. But we know that it's all about the area above and below the x-axis rather than the y-axis. So that's not a correct option for this question. Now for part C, this is starting to look correct because we have the integral from 1 to 4 of f of x dx, which would give this area above the x-axis. And then we add on two lots of the integral between 4 and 6 of f of x dx, which is this part here that by symmetry looks like it's also that part there. Now the issue here is we're adding on, and that signed integral would be a negative value because it's below the x-axis. So unfortunately that's not correct, although if you subtracted two lots of that integral off, it may be considered correct. The only issue is we don't actually have any information that this is a perfectly symmetric function. So for option D, we now have negative the integral from negative 1 to 1 of f of x dx. So if we start to colour code this bit here would actually find this, and the negative out the front would make it positive. So that bit is good. And then we add on the integral between 1 and 4 of f of x dx, and that would find the area under the curve in this green part here. And finally we subtract away the integral of 4 to 6 of f of x dx. So 4 to 6 of f of x dx would find this signed area here, and it would be a negative value. And then by adding the negative out the front, it would add on a positive area. So it turns out that D is the correct answer for this question. E is almost the same, however they've swapped the terminals of this integral, so it's negative the integral of 6 to 4. So that there would already make the value positive by swapping the integrals, but then the negative here means we're subtracting away that area rather than adding it on. So that's a close distractor, and you'll see on the next slide that a few students did get tricked by that one. So the examiner's report for this shows that 81% of students got this correct, so this was very well done for this exam. And we can see that 9% of students picked that close distractor as part E, even though there was just something slightly wrong with it.